Hey everyone, welcome to my channel. Today, we're diving into the fascinating world of optical illusions. Those mind-bending images that trick our brains into seeing things that aren't quite as they appear. Our brains are incredible organs, constantly processing information from our senses to make sense of the world around us. But sometimes our brains can be fooled, especially when it comes to visual perception. Get ready to put your perception to the test as we explore a series of captivating optical illusions. I encourage you to pause the video before each reveal and see if you can figure out the trick behind each illusion. It's going to be a wild ride, so buckle up. Alright, let's kick things off with a classic, the Muller-Lyer illusion. Take a look at these two lines. They might look like something pulled straight out of a geometry textbook. Notice anything peculiar about the arrows or fins at the end of each line? One set points inward and the other points outward. Now, focus on the lines themselves. Which line appears longer? Go ahead, take your time and make your guess. Don't let those arrows sway your judgment, or will they? Ready for the reveal. It turns out both lines are exactly the same length. This illusion highlights how our brains interpret depth and distance based on visual cues. Those outward-pointing arrows trick our brains into thinking that line is extending further away, making it seem longer. Next up, we have a captivating illusion that's sure to get you thinking. Feast your eyes on this silhouette of a graceful dancer. She's moving to the rhythm, but which way is she twirling? Is she spinning clockwise or counterclockwise? This one's a real brain teaser. You might find that the dancer switches directions right before your very eyes. It's like she's defying the laws of physics. How is this even possible? Well, the spinning dancer illusion plays with our perception of depth. Because the silhouette lacks visual cues for three-dimensionality, our brains try to fill in the gaps, leading to multiple interpretations of the dancer's movements. The direction you perceive her spinning can actually reveal which side of your brain is more dominant at that moment. It's a fascinating glimpse into the complex workings of our minds. Chapter 3. The Checker Shadow Illusion. A trick of the light. Get ready to question everything you thought you knew about color with the checker shadow illusion. In this illusion, we have a checkerboard pattern with a cylinder casting a shadow across it. Focus on the squares marked A and B. One square resides in the shadow while the other sits in the light. Now, here's the million-dollar question. What color is square A and what color is square B? Most people would swear that square A is a darker shade of grey than square B. But here's the mind-blowing truth. They're actually the same color. Our brains struggle to perceive colors accurately when they're shrouded in shadow. We tend to compensate for the perceived darkness, making objects in shadows appear darker than they actually are. Chapter 4. The Penrose Triangle, an impossible object. Prepare to enter the realm of the impossible with the Penrose Triangle. This mind-bending shape, also known as the impossible triangle, has been baffling viewers for decades. Take a moment to examine its unique structure. What do you notice about its sides and corners? Can you figure out how this shape could possibly be constructed in the real world? Here's the catch. The Penrose Triangle is a two-dimensional representation of an object that cannot exist in three-dimensional space. It's a clever manipulation of perspective that creates the illusion of a three-dimensional object. Our brains are wired to interpret lines as representing edges and corners in 3 dimensions. The Penrose Triangle exploits this by presenting us with lines that seem to form a coherent object, even though it's geometrically impossible. Chapter 5. The Ames Room. Shrinking and growing before your eyes. Get ready to question your sense of scale with the Ames Room illusion. Imagine stepping into a room where people seem to magically shrink or grow depending on where they stand. In this illusion, we have a specially constructed room that plays tricks on our depth perception. Notice how the shape of the room distorts the apparent sizes of the people inside it. The Ames Room is a brilliant example of how our brains rely on visual cues to judge size and distance. The room's trapezoidal shape and the slanted floor and ceiling create the illusion of a rectangular room when viewed from a specific angle. Our brains assume that the room is rectangular, so when someone walks from one side to the other, their perceived size changes dramatically, even though they haven't actually grown or shrunk an inch. Wow, what a journey through the fascinating world of optical illusions. We've seen how easily our brains can be tricked by visual cues, from distorted lines and shapes to clever manipulations of light and shadow. Remember, these illusions aren't just cool tricks. They reveal the incredible complexity of our brains and how we perceive the world around us. So, the next time you encounter an optical illusion, take a moment to appreciate the amazing cognitive processes at play. Now it's your turn. Share your favorite optical illusions in the comments below and let me know which one blew your mind the most. Don't forget to like and subscribe for more mind-bending content. Until next time, keep exploring the universe and never stop questioning what you see.